There are strong attractive electrostatic forces between particles that produce strong intramolecular bonds. In this 3-minute lesson, we shall introduce other much weaker electrostatic interactions and describe how these form weak bonds between particles. These weak intermolecular interactions occur in all substances.
Atoms consist of a positively charged nucleus shielded by negatively charged electrons. The effectiveness of this shielding depends on the symmetry of the electron density across the particle. Asymmetric distribution of electrons produces a weak dipole. This is because a decrease in the electron density partially exposes the positive charge beneath. Areas of increased electron density lead to a small net negative charge. The attractive electrostatic forces between these adjacent dipoles are called dispersion forces. These are extremely weak interactions. In a polar molecule, atoms with different electronegativity lead to permanent dipoles being formed across the molecule. Electronegative atoms have a relatively small atomic radius and high nuclear charge. Such atoms can draw the shared electron pairing covalent bonds closer, producing a dipole across the bond. This leads to permanent dipole-dipole interactions between adjacent molecules. Molecules containing highly electronegative atoms, when combined with hydrogen atoms, produce electrostatic interactions significantly stronger than other intermolecular forces. These are molecules containing fluorine, oxygen or nitrogen atoms which interact with adjacent hydrogen atoms. The resulting force between molecules is called a hydrogen bond. The relative strength of hydrogen bonds compared to dispersion forces and dipole-dipole interactions lead to significant differences in the physical properties of these substances, for example in hydrogen fluoride, in water and in ammonia. When substances dissolve, the solute and solvent particles mix. The solution contains attractive electrostatic forces between the solute and solvent particles. For substances to be soluble or miscible, the forces between dissolving solute and solvent particles must be equivalent. That is, polar dissolves polar, nonpolar dissolves nonpolar, but nonpolar and polar do not mix. These include interactions between individual ions and dipoles across polar molecules, called ion dipole forces. Soluble ionic compounds dissociate in water, forming ion dipole interactions. The dipole's negative side interacts with positive ions, and positive side interacts with negative ions. The resulting solution is called an aqueous solution.
The properties of substances are dependent on the type of bonding involved. In the next 3-minute lesson, we shall examine examples where the types of bonding between particles is less precise, resulting in unexpected properties in some substances.